guys, so I'm going to show you how to use StatCrunch to compute all of the different measures of central tendency and variance that you learned about in Nick's video. And so what I've done is I've taken the data he gave about the temperatures in May and I've put it here in StatCrunch. And I'm going to show you how to calculate the mean, the median, the mode, and then the standard deviation if this was a population and if this was a sample. So let's start with the mean. Right? If we wanted to find the average temperature in May, how could we do that using StatCrunch? So what you're going to do is you're going to come over here to Stat. And of course you have to put in your raw data first. Come over here to Stat, and you're going to go to Summary Statistics because all of these things that we're talking about are summary statistics. You'll choose Column because we have our data going up and down in the column. And the variable that we want to select is temperatures in May. You always need to select a variable. That's very important. So if we want to know the mean, the average temperature for the month, we just click mean and compute, and there it is. And if we were to go through by hand and add up 66 plus 68 plus 67 plus 57 plus 54 plus 57 plus 51, and then divide it by 7, right, which is our sample size here, our population that we've got, we would get 60 degrees. Okay, so the average temperature in May was 60 degrees. Now let's look at the median. And remember, the big difference between mean and median is that mean takes into account every single data point. We have to use every data point. We have to add it up and average, right? All of these data points to find the mean. Whereas median is just a position, right? It's like if we lined up all our data points and just looked right smack dab in the middle. So they are different. But how would we find that? So again, we're going to Stat. It's still a summary statistic. We're going to Columns. We always have to select our variable, only now we're just going to select median. Where is it? Here it is. And then I click compute. So if we lined these up in ascending order from smallest temperature at 51 degrees all the way up to largest temperature at 68 and filled in all the temperatures in between, and we looked right smack dab in the middle, we would hit 57 degrees. And this is a nice data set. It's an odd number, so we wouldn't even have to average the center too. There would literally just be 57 right in the middle. So the median temperature in May is 57 degrees. Well, what about the mode? And all you have to do is just take a look at this data, guys. There's only 7 data points, and you can see that there's one temperature that occurs more than once, right? Again, mode means which data point occurs with the most frequency, the highest frequency. There's only one data point that appears more than once, and so we would expect that to be our mode. Take a second, see if you can figure out what it is. And so now I'm gonna go to Stat, Summary Stats, Columns, always click my variable, and then mode is down here at the bottom. Okay, and again, the mode of our data here is 57 degrees. It occurs the most frequently. Okay, but typically we would use mode when we're talking about qualitative data, not necessarily quantitative data, because mean and median are going to be much more accurate in determining like the center of our quantitative data. Mode we would use for qualitative data if we wanted to figure out what's happening the most often. All right, this is just to show you how to calculate it in StatCrunch. Well, what about if we wanted to find the standard deviation? Now, like Nick said in his video, there's 2 different ways. It's really dependent on whether we're talking about a standard deviation for a population or for a sample, right? Because when we're talking about a sample, we have to correct for that bias. And instead of dividing by n, we're going to be divided by n minus 1. So remember, when we're talking about standard deviation, we're talking about how far away from the mean is each data point, right? How much variance is there here? How far away is each data point from the mean, from the middle, okay, from the average of our data set? And, how do we calculate that, right? We find the difference that each data point is away from our mean. Then we have to add them all up. We square them to make them positive, and we divide by n. Okay, so we're basically just averaging differences. And then of course we have to take the square root because we squared. But we're just finding the average difference of each point, the average amount of variability there is. So when we're doing that for a population, well, we just divide by the population size. But when we're doing that for a sample, we have to sort of adjust for that bias, and we divide, instead by n, we divide by n minus 1. Okay, so I'm going to show you how to calculate both. So let's say we want to find the standard deviation for, let's pretend this is just our sample. This is a sample, okay? This is representative of a sample, which it is, basically. Then we need to adjust for that bias, right? So if we're assuming this is a sample, then we need to find the sample standard deviation, which has to be adjusted for that bias. So we're dividing not by n, but by n minus 1. So we're going to go to stat, summary statistics column. We always have to click our variable. And we are going to click standard deviation, okay? We compute that. And just like Nick got, he got 6.87, right? If you went back to his video, or I think he said, 6.88, we have to round up. If you went back to his video and you compared it with what he got, that's what he got. So that would be for our sample. But what if this was for our entire population? What if this represented the entire population? Okay, well then we would just be dividing by that population size n, right? So how do we find that? We go to stat, summary statistics, columns. Again, we're going to go to temperatures in May, but now we're going to go down here to the unadjusted standard deviation. We did not have to adjust for the bias because now we're dealing with an entire population, okay? We don't have to adjust for anything because that variance is already built in. So we can just take the unadjusted standard deviation, click compute, and there we get that 6.37 that we saw from Nick's video. So that is how you would find all of these different measures of central tendency and variance in my StatCrunch. And like Nick said, it's really good to know how to do these things by hand because it really helps us understand what they mean and where they're coming from, right? Like when we do outmean by hand, we can see that we're just taking an average. And when we think about standard deviation, to just look at that formula is very confusing. But to understand where it's coming from one step at a time, right? First, we're taking each data point and we're finding the difference between the mean and the data point. We're saying, what's the distance from the mean to this point? How far away are they from each other, right? Then we're adding them all up and averaging them, okay? So we're just finding the average amount of variance, how far away these things are from the mean, from the middle, basically. So it's important to do these things by hand so you really do understand what's happening. But once you understand that, technology is the much better way to go about it, right? Technology isn't going to make silly mistakes. Technology is much more efficient, especially for large data sets. We wouldn't want to do that out by hand. So it's really important to know how to do these things, both by hand, so you know where it's coming from and what it means, but also using technology so that you know how to do it quickly and efficiently. And then you can start interpreting those results.